Good day everyone. Integration part 12. Now I am going to teach you a new type. Now from this example sum, I will tell you what is this type and what are all the changes and how we can generalize it. Now consider this. I is equal to integral 1 by x power 4 plus 1 dx. In the numerator you have 1. In the denominator you have x power 4 plus 1. You know x power 4 plus 1 is not factorizable, right? So, we should have some special method for this particular sum. Now, the 1 in the numerator, I am actually going to write it as x squared plus 1 minus x squared minus 1. X squared and x squared will get cut. 1 plus 1 will be 2. To compensate, I can have a half. Okay, do you follow? The 1 in the numerator, you have to write it as half into x squared plus 1 minus x squared minus 1. So now I will write here, half I will write this side, x squared plus 1 minus x squared minus 1 by x power 4 plus 1 dx. You split it into two integrals now. You will be getting half bracket integral x squared plus 1 by x power 4 plus 1 dx. Okay? Minus integral x squared minus 1 by x power 4 plus 1 dx. So I can write it as I is equal to half into I1 minus I2. Call this as step 1. So what we have done, the 1 in the numerator you are writing like this. Then you are splitting it into two integrals, taking the half common out. Okay? Now, this particular part, that is the I1 part, that can be asked as a separate sum. Similarly, the I2 part can be asked as a separate sum. Here, you have a 1 in both. Immediately, don't think always you will have 1. No need. But first, let us deal with this. Then I will tell you how other numbers will come like that after finishing this one. Okay? So now, we have to do I1, I2 as two separate sums. So let me take I1. I1 is equal to integral x squared plus 1 by x power 4 plus 1 dx. Now, within the integral, you take x squared common from the numerator and from the denominator. So, what will I get now? X squared into 1 plus 1 by x squared. Here, x squared into x squared plus 1 by x squared dx. Cut this x squared. Right? Now, I want to substitute something as t so that my numerator will become dt. That is actually the integral of this part I will substitute. So, if I substitute x minus 1 by x as t, here you have a plus, no? If you have here x minus 1 by x, when you differentiate you will get 1 minus of minus 1 by x squared, that will become plus 1 by x squared. So, you will get 1 plus 1 by x squared dx. That will become dt. So, if this is t, the numerator will become dt. Fine. What about the denominator? Now, we don't have anywhere this x minus 1 by x. So, how can we write the denominator in terms of t, right? Now, let us square this. That is, x minus 1 by x the whole square is equal to t square. That gives you x square plus 1 by x squared minus 2 is equal to t square. So, the x squared plus 1 by x squared, that is the denominator, will become t square plus 2. Okay? So, the denominator is t square plus 2. The numerator is just dt. Is it clear? Now, so now the I1 will be equal to integral. The numerator is dt. The denominator is t square plus 2, which is root 2 the whole square. You know this is easily integrable, isn't it? So it is like integral dx by x squared plus 1, x squared plus a squared. So 1 by a tan inverse x by a. So here you will get 1 by root 2 tan inverse t by root 2 plus c1. Now let me write in terms of x 1 by root 2 tan inverse. What is t? T is x minus 1 by x. So I will get x minus 1 by x by root 2 plus c1. I want to simplify it a bit. So I can write 1 by root 2 tan inverse. If I take x as the LCM, I will get x squared minus 1 by root 2x plus c1. Mark it as step 2. So the I1 is over. Now let us come to I2. What is I2 now? I2 is equal to integral x squared minus 1 by x power 4 plus 1 dx. Here also follow the same procedure. Take the x squared within the integral. You will get 1 minus 1 by x squared into x squared plus 1 by x squared dx. Cut the x squared. Now you are having 1 minus 1 by x squared in the numerator. So now substitute x plus 1 by x is equal to, there you have put it t. Now let us put some other variable. I will put z. So x plus 1 by x is equal to z. Okay. So now if I differentiate, I will get 1 minus 1 by x squared dx. That will be equal to dz. Then as I have done that, I will square this. So x plus 1 by x the whole square will be equal to z squared. That is x squared plus 1 by x squared plus 2. That will be z squared. So x squared plus 1 by x squared is z squared minus 2 now. There you got t squared plus 2. Just comparatively look at the I1 and I2 so that it will be clear to you, right? So here you got z squared minus 2. So now coming to the I2. Now I2 will be integral. The numerator is dz. The denominator is z squared minus root 2 the whole squared. You know the formula. Integral dx by x squared minus a squared. That will be 1 by 2a log mod x minus a by x plus a. Using that formula, you will be getting 1 by 2 root 2 log mod x, that is z here, okay? Z minus root 2 by z plus root 2 plus c2. Now what is z? X plus 1 by x. So we will get here 1 by 2 root 2 log mod x plus 1 by x minus root 2 by x plus 1 by x plus root 2 plus c2. We can take x as the LCM in both the numerator and denominator. The x will actually get cut. So you will be getting 1 by 2 root 2 log mod x squared plus 1 minus root 2x by x squared plus 1 plus root 2x plus c2. Mark this as 3. So do you follow how to integrate the I1 and I2 clearly? In the I1, you are having here 1 plus 1 by x squared. So you substituted x minus 1 by x as t. There the denominator you got t square plus 2. So the formula was some tan inverse. In the I2, you got 1 minus 1 by x squared dx in the numerator. So you substituted here x plus 1 by x as z. And you got in the denominator z squared minus 2. So you got a different formula here. Now the 2 and 3 we have to substitute in 1. That's all. Okay. Can we substitute the 2 and 3 in 1? We are going to substitute 2 and 3 in 1. So I will be equal to half is outside. I1. Where is your I1? 1 by root 2 tan inverse x squared minus 1 by root 2x. Leave the c1. Last we will put one c. Then minus I2. So minus 1 by 2 root 2 log mod x squared plus 1 minus root 2x by x squared plus 1 plus root 2x. Close the bracket plus c. Instead of that c and c2, c1 and c2, put 1c. Now, this half we can bring inside. So, you will get 1 by 2 root 2 tan inverse x squared minus 1 by root 2x minus this 2 if you bring here you will get 4 root 2 log mod x squared plus 1 minus root 2x by x squared plus 1 plus root 2x plus c. Do you follow? So, this is a bit lengthy, but this is an important model sum we can call it. So, first you should remember the 1 in the numerator how to write. Half into x squared plus 1 minus x squared minus 1. Then split it into two integrals. I1, I2. I1 how to do? I2 how to do? Learn it comparatively. And then you substitute both the results in your I. Is it clear to you? Now, I will explain how this model will be useful and what can be the changes, etc. Now, I have done this sum, right? 1 by x power 4 plus 1. In that, we got these two as two parts, that is I1 and I2. You got x squared plus 1 by x power 4 plus 1. You got x squared minus 1 by x power 4 plus 1. So, you know this, isn't it? You know this. If they give you separately this, you know how to do. If they give like this also, you know how to do. Now, it need not be always only that x power 4 plus 1. You can have some x squared term also. The method is the same way. You can have 1 by x power 4. Then there can be some x squared plus 1. Similarly, here also you can have some x squared. Here also you can have some x squared. But the procedure is the same way. Okay? Then, always there need not be, it is no condition that it will be 1. But how it will be? Supposing you have 1, here 1. Suppose you have 4 in the numerator, here it will be the square. That will be 16. If you have 9, you will be having 81. That will be the change. When that happens, how you have to assume that t part, that alone I want to tell you by one example. So, for all these type of sums, the procedure, the main procedure, the concept is same thing. Okay. Now, let me tell you, when it is not 1, how to go about, and then tell you what other sums we will be using this concept. Now, look at this sum. I is equal to integral x squared plus 4 by x power 4 plus 16 dx. Already I told you, whatever be the number here, the square will be here. Okay. So, first procedure, that is the first step is same. Take x squared common within the integral. That is the first step. So, what will I get now? X squared into 1 plus 4 by x squared into x squared plus 16 by x squared dx. This will get cut. Okay. Now, how to take it? Here you cannot take that x minus 1 by x as t. Okay. Here, because you have a plus here, that is going to be minus in between. There is no doubt. But x squared, the square root is x. 16 by x squared, the square root is 4 by x. Put a minus. This you have to substitute as t. Do you follow how to find it out? If you have a plus, here there will be a minus. If you have a minus, you will have a plus. Then only when you differentiate, you will get it. Then, to fix this term, take the square root, take the square root. If you have 25 by x squared, take here 5 by x. If you have 81 by x squared, take 9 by x. Okay? So now, x minus 4 by x, you take it as t. So when you differentiate, you will get 1 plus 4 by x squared dx. That will be equal to dt. The numerator will definitely become dt. Now, for the denominator, you square this. X minus 4 by x the whole square is equal to t square. X square plus 16 by x square. Now the 2ab term, no, 2 into x into 4 by x. The x and x will go. You will get minus 8. You won't get 2 now. You will get 8. That is equal to t squared. So you will get x square plus 16 by x square. That is the denominator is t square plus 8. Is it clear? What are all the changes we are getting here because there is no one here. Right. Now let me write that I is equal to integral. The numerator is dt. The denominator is t square plus 8. 8 means it is 2 root 2 the whole square, correct? 8 is 2 root 2 the whole square. Now the formula is, when you have a plus like this, it is tan inverse formula. So you will be getting 1 by a tan inverse x. In that place you will have t by 2 root 2 plus c. Now what is t now? T is x minus 4 by x. So you will get 1 by 2 root 2 tan inverse x minus 4 by x by 2 root 2 plus c. Take x as the LCM. So 1 by 2 root 2 tan inverse x squared minus 4 by 2 root 2x plus. Once you understand the method and the steps how to proceed, then it is easy only. So here, first of sums of this type, take x squared common out. From the numerator and denominator, cut it. Then if you have a plus here minus, if you have a minus here plus, take the square root, take the square root, right? Then the numerator will definitely become the dt. Then square this and then whatever number you get, take it that side. You will either get that x squared plus a square or x squared minus a square. Use the appropriate formula. Is it clear? To integrate root tan x and root cot x, you will be using this concept I taught you. Okay? So, I will do root tan x for you now. You have to do root cot x yourself. Now, I is equal to integral root tan x dx. Now, first, there is no algebra part here. So, we have to use some substitution and then we will bring that format and then we will go to that type what I taught you now. Now, I will take the total thing, that is root tan x as t. If I square, I will get tan x is equal to t square, right? I will get tan x is equal to t squared. So now, when I differentiate it, I will be getting secant squared x dx. That will be 2t dt. Secant squared x can be written as 1 plus tan squared x dx is equal to 2t dt. Tan x is t square. So tan squared x will be t power 4. So I will be getting 1 plus t power 4 dx is equal to 2t dt. My dx will be 2t by 1 plus t power 4 dt. Do you understand this part first? So first I am substituting root tan x. If it is root cot x, you substitute that. Okay? That as t. Then square it. Tan x will become t squared. Now differentiate both sides. Secant squared x dx is 2t dt. Secant squared x you write it as 1 plus tan squared x. Tan x is t squared. So tan squared x will be t power 4. So you get like this. So dx you get in terms of t now, right? So now let us move on to our I. I will become now integral root tan x. So that is t. Okay. Dx that will be 2t by 1 plus t power 4 dt. So what do I get? 2t squared by 1 plus t power 4 dt. I will write it as 2t squared by t power 4 plus 1 so that the format will be clear to me. Now, previously you had your 1 in the numerator that we write it as, no, we wrote it as half into x squared plus 1 minus x squared minus 1. Now I have here 2t square. So I am going to write this as t squared plus 1, okay, plus t squared minus 1. What will you get? 2t squared. Plus 1 and minus 1 will go. Because I always need, when I have a denominator t power 4 plus 1, I need either t square plus 1, t square minus 1. Then only it will come to the pattern. It will come to that concept what we have already learned. T power 4 plus 1 dt. So now you can split it into two integrals. So your I will now become integral t square plus 1 by t power 4 plus 1 dt plus t square minus 1 by t power 4 plus 1 dt. Write it as I is equal to I1 plus I2. Now we have come to that pattern what you learned, correct? So now this is a separate sum, that is a separate sum. Instead of x you are having a t, that's all. So here first substitution x in terms of t. Now there will be another substitution. So there will be two substitutions and you have to go back to x in the last step. Okay. Now first let me take I1. I1 is, I will take the t square out. So 1 plus 1 by t square. I will take a t square out. This you know already. T square plus 1 by t square dt. Cut this. What to substitute now? You are having 1 plus. So there will be a minus now. And I told you the square root of this, the square root of that. That will be equal to, let me write some z. Okay. So t minus 1 by t is equal to z. So when I differentiate, I will be getting 1 plus 1 by t square dt, that will be equal to dz. So that numerator becomes now dz for me. Then coming to the denominator, we will square this. T minus 1 by t, the whole squared is z squared. So t square plus 1 by t square minus 2, that is equal to z squared. So now t square plus 1 by t square is z square plus 2. So you will get your I1 is equal to integral dz by z square plus root 2 the whole square. I think now you will be familiar, no? Because we have done actually two sums of this model. So now you will get 1 by root 2, okay? Tan inverse z by root 2 plus c1. Now for z, I have to first substitute in t, then I have to go back to x. So now first I will write 1 by root 2 tan inverse. Z is t minus 1 by t by root 2 plus c1. Right? This I can write it as 1 by root 2 tan inverse t square minus 1 by root 2t plus c1. Now t is root tan x. T square is tan x. So now I will get 1 by root 2 tan inverse. T square means tan x minus 1. This is root 2, that is root tan x. So I will get root 2 tan x plus c1. This is my 2. Is it clear? So this part you already know. Only this is a bit different. You got. Then now we have got I1. Similarly, we have to do I2. And then we have to substitute in 1. I is equal to I1 plus I2. Okay. Now let us go for I2. Right? Now, I2 is integral t square minus 1 by t power 4 plus 1 dt. So the first step you know. Take t square. 1 minus 1 by t square. Take t square plus 1 by t square dt. Cut it. Fine. Now, we have to substitute. Because you have a minus, you will be getting a plus. Here you have a z, so substitute some other letter. So now I will write t plus 1 by t, let it be equal to sum s. When I differentiate, I will get 1 minus 1 by t square dt, that will be equal to ds. Then square it. T plus 1 by t the whole square is equal to s squared. Okay. So you will get t square plus 1 by t square plus 2. That will be equal to s squared. So t square plus 1 by t square is s squared minus 2. Right? So now the I2 will be integral ds by s squared minus root 2 the whole square. What is the formula here? That 1 by 2a log mod x minus a by x plus a formula. So you will get 1 by 2 root 2 log mod s minus root 2 by s plus root 2 plus c2. Now from s I will go back to t, then I have to go back to x. So now I will get 1 by 2 root 2 log mod s is t plus 1 by t. So t plus 1 by t minus root 2 by t plus 1 by t plus root 2 plus c2. Okay. Now I will take LCM. So the t will go. So we will get 1 by 2 root 2 log mod t square plus 1 minus root 2t by t square plus 1 plus root 2t plus c2. Now, from t, I have to go back to x. You know, t is equal to root tan x and t squared, that is equal to tan x, right? So, now you will get, it is 1 by 2 root 2 log mod t squared is tan x plus 1 minus root 2 tan x by tan x plus 1 plus root 2 tan x plus c2, this is 3. Now we have to substitute 2 and 3 in 1. 1 is very simple. I is I1 plus I2. So now you will get I is equal to I1. What do you have in I1? It is 1 by root 2 tan inverse tan x minus 1 by root 2 tan x, right? Then coming to I2, you will get 1 by 2 root 2 log mod tan x plus 1 minus root 2 tan x by tan x plus 1 plus root 2 tan x. Combine that C1 and C2 and write 1C. Very big sum, isn't it? But if you just practice it, it will be okay. It is worth 5 marks. So you should know it. So root tan x and root cot x, the same way you have to proceed. So you practice that root cot x. So today actually you have learnt maybe just 3 sums. But everything is a big one and a new concept, isn't it? So first practice this till it gets registered in your mind. And then we will go to some special sums and I will just mention a few more concepts. But they are not very important, I will say, but you should know the concepts and all. So that we will see in the next video. Thanks for watching the video. Share it with your friends and classmates. Thank you once again.